Salam Sejahtera. In this video, I will teach the topic of straight line. However, our today lesson is only cover the learning outcome of 9.1.4. Before we start to the lessons, I would like to introduce myself first. My name is Elynncy Fyncia Anak Mekelan. I hope that everyone can pay for attention to our today lesson. Please take note, our today lesson only focus on a subtopic of gradients of parallel lines. The objective is to study on how to determine whether two straight lines are parallel with each other based on their gradient value. At the end of this lesson, students should be able to investigate and make inference about the gradients of parallel lines. Okay, we start with a quick recap. Do you still remember what is the equation of the straight line? The equation of the straight line is y equal to mx plus c, in which m represents the slope while c represents the y-intercept. The gradients of the line tell us how steep the line is. Are you ready to do our first activity? In this activity, we will relate the application of gradients with the real-life situations. Let's observe the picture that I have created in this GeoGebra together. The pink block is represent the wall. The blue line is straight line which slope equal to the tree. And the red line is straight line with slope equal to the 1/2. In fact, the bigger the gradient, the steeper the line. As we can see here, a gradient of 3 generates a line that is much steeper than the gradient of 1/2. We also can relate this with real-life situations, such as climbing a ladder. If the ladder is really close to the wall, the gradient of the ladder is really steep. Taking the base of the ladder away from the wall means that the gradient of the slope decreases, reaching a lower point on the wall. For the second activity, we need to investigate the relationship between the value m and the form of a straight line graph using GeoGebra. Firstly, let me see what will happen if the value of m is positive. Create a straight line graph by type y equal to mx. Since we focus on the positive value of m, therefore we need to change the setting for the slider m, where minimum is equal to 0 and maximum is equal to 5. For your information, we should observe the form of a straight line graph from left to right. In this graph, we can clearly see that the straight line is moved upward. Next, what will happen if the value of m become negative? As usual, we need to change the setting of slider m first in order to fulfill the condition with m is equal to -5 and maximum is equal to 5. What can you observe when I move the slider m? It can clearly be seen that the straight line is moving downward. What is y-intercept? Y-intercept is the point of intersection between the straight line y equal to mx plus c and the y-axis. For activity 3, analyze the effect of the changes in the value of c on the graph using GeoGebra. Starting to write y equal to mx plus c to create a graph of straight line. Go to the setting, change the color, increase the line thickness and line capacity. This step is optional and the graph can be set depending on what you like. Next step, we need to find the y-intercept. Go to the menu, click the second symbol and choose intersect. Click the y-axis and the straight line. The point A is the y-intercept. Let me put the caption by go to the setting. What can you observe when I move the slider C? Increasing C, shift the line up in the plane. In contrast, decreasing C, shift the line down in the planes. Now, let's look together the video that I have prepared. Can you imagine the world without mathematics? Let's see what would have happened if there were no parallel lines. Oh no! There was a car accident. When two lines on the same plane do not intersect, they are known as parallel lines. Road as well as roadway tracks are always parallel. Mostly, bridges are also parallel. Aha! The ladder too is parallel. Instruction for activity 4 is, by using GeoGebra, create two straight lines that are parallel with each other. Find the gradient for both straight lines and identify the similarities found in these two straight lines. The first step is form a straight line graph by type the general equation of straight line, which is y equal to mx plus c. Go to the setting, change the colors, increase the line thickness and capacity. I also label this straight line as EQ1. Next step, we want to find another straight line that is parallel with the first straight line. Therefore, go to the menu and click the fourth button, choose parallel line. Click the first straight line and click at any point. Yay! We are successfully create a second line that is parallel to the first line. I'm gonna set the second line with green colors and label it as EQ2. In order to make this picture look more clear, I will remove the axis and the grid. The most important step is find the gradient of these two straight lines. Click on the button, choose slope, and click on each of the straight line. The gradient values for both graphs have been indicated. As we can see, both of the straight lines that are parallel with each other has the same value of gradients. From the previous activity, we can conclude that two or more straight lines are parallel when they share the same gradient. Please take note on this definition since we will use it later to make a conclusion. For further explanation of the definition we just learned, let's watch a YouTube video together.
Hi, now in this short tutorial what I want to do is just show you the relationship between the gradients of parallel lines. Now these two lines, the red and the blue, are clearly not parallel. Parallel lines, as you should know, are lines that go in the same direction. They share the same gradient, so these two red lines are parallel. Let's just put that there. And when it comes to the blue line, obviously a parallel line would be something like that. They share the same gradient. What is that gradient? Well, just as a quick reminder, if we're looking at the red line here, we measure gradient by going 1 unit towards the right in the positive x direction and see what happens to y. So as we move 1 unit in the positive x direction, y increases by 2 units. So this has a gradient of 2, and so will this line here have exactly the same gradient. For every 1 across, it rises 2, 1 across rises 2, and so on. And for the blue lines, well, their gradient is going to be -3, and you can see that because for every 1 unit across in the positive x direction, y drops by 3 units. You can see it clearly here, okay, as we go down there. As x goes to the right 1 unit, y drops 3 units. So what I'm saying then is, in short, that if 2 lines are parallel, then the gradients are going to be equal. This might have seemed obvious to quite a few of you, but it is an idea, a concept that you're going to use time and time again when you're asked to find the equations of 2 or more parallel lines. You use that idea that the gradients are equal.
Now, we will learn the most important step in this subtopic. There are 4 main steps to determine whether 2 straight lines are parallel with each other. The first step is rearrange the equation of straight line in the form of y equal to mx plus c. The second step is list out the gradient value for both straight lines. The next step is we need to check whether the gradient of both straight lines are equal or not. Lastly, make conclusions whether the straight line is parallel by referring the gradient value of both straight lines. Please remember all of these steps since we will use it later to solve the problem. I have already explained the theory. Now, let's try to solve the example together. The question is determines whether the straight line y minus 3x equal to 10 is parallel to the straight line 3y equal to 9x minus 12. Based on the step that we just learned earlier, the first step that we need to do is rearrange the equation in the form of y equal to mx plus c. For the first equation, we move the 3x to the right hand side and the equation becomes y equal to 3x plus 10. For the second equations, we need to divide all the equation by 3 and the final equation is y equal to 3x minus 4. The second step is we need to determine the value of gradients. Both of the straight line has the value of gradients equal to 3. Before we proceed to the next step, let's recheck the solution by using the GeoGebra first. Let's rewrite the first equation, which is y minus 3x equal to 10. Meanwhile, the second equation is 3y equal to 9x minus 12. I'm gonna change the color of these two straight lines so that the student can distinguish them easily. We already learned on how to find gradient by using GeoGebra from the previous activity. Just click the slope and choose the straight line. M1 and M2 equal to 3. The GeoGebra show the same value of gradient with what we have solved manually just now. That means our solution is true. However, we are not done yet since we have not answered the questions. For the third step, do they have the same gradient value? Yes, obviously, their gradient values is equal. Before we make a conclusion, let's recall back the definition, which is straight lines that have the same gradients are parallel. Therefore, what we can conclude is the line y minus 3x equal to 10 is parallel to the 3y equal to 9x minus 12. Let's move on to the next example. Given 4 different equations of straight line, identify the equations that are parallel to each other by first finding their slope. Anyway, let's rewatch an explanation from a YouTube video on how to find the gradient from the equation of the straight line given in the question.
Okay, so let's say we're given the equation of this line, and here you're being asked to find the gradient of a line parallel to it. Without even knowing where the line is, because you know that parallel lines have the same gradient, since the gradient of this line is 2, the gradient of a line parallel to it is also 2. With this equation, remember the gradient is the coefficient on x, not the first number. So that's really 6 plus negative 1/3. The coefficient on x is negative 1/3. So the gradient of this line is negative 1/3. And the gradient of any line parallel to it is also negative 1/3. Okay, these are a little bit trickier because we don't have y equals. So in fact, we have to do a little bit of equation solving here. So the first thing I'm going to do is divide everything through by 2. The reason is I want to get y equals, so I need to get rid of the 2. They cross out. Y minus 4 divided 2 is 2, and 14 divided 2 is 7, and then add 2x to both sides. I'm doing basically making y the subject, which is something we learned to do back in term 1, and therefore y equals 7 plus 2x, which I prefer to write as 2x plus 7. So the question is, what's the gradient of a line parallel to this? Well, because this has a gradient of 2, a line parallel to the given line also has a gradient of 2. Okay, similarly, we need to make y the subject of this equation just here. So the first thing I'm going to do, I'll get the 3y by itself. So I'll subtract 2x from each side. Like so. That crosses out, leaving just the 3y equals 6 subtract 2x. That of course can't be simplified because they're not like terms. We can't write it any simpler than that. And finally, everything has to be divided by 3. And there's the equation. Y equals 6 divided 3 is 2. Minus and I'm going to write that as 2/3 x. That's not very neat. Let me see if I can improve on that. 2 minus 2/3 x. And once again, that's the equation. That's the same equation as that, just rewritten. The gradient is negative 2/3. So for any line parallel to that, the gradient is also negative 2/3. So that's just about all you need to know about the gradients of parallel lines.
Based on the gradient values that have been calculated, we can conclude that y equal to 2x minus 5 is parallel to the 2y minus 4x equal to 14. For activity 5, solve the following question using GeoGebra. Let's read the question together. Question 1. Find the slope of straight line equation 4x minus 2y equal to 12. The equation for the question 1 is 4x minus 2y equal to 12. Click on this symbol, choose slope and click the straight line. Therefore, the answer that we got is m is equal to the 2. Question 2. Find the slope of straight line 3y minus 18 equal to 15x. The equation for the second question is 3y minus 18 equal to 15x. Repeat the same step. Choose slope and click the straight line. So the slope for the second equation is equal to the 5. And for the last questions, based on question 1 and 2, determines whether these two straight lines is parallel with each other. Justify your answer. For the question 3, just look at the graph of both straight lines. We already know that they are not parallel with each other. To prove it, we can check whether they have same value of gradients or not. Based on the answer that we got from previous questions, we can conclude that they are not parallel with each other since m1 is not equal to the m2. We already done answer this question, and this is the overall answer for the question in activity 5. As your homework for today's lessons, I hope you can solve this question manually and check if you can get the same answer with what we have discussed. We have reached the end of the lessons. Therefore, you should be able to determine the gradient values by rearranging the equation of the straight lines and make inference based on the gradient values. The flowchart shows the summary of our today's lessons. Firstly, in order to determine the gradient value of a straight line, we need to change the equation of the given straight line to the form y equal to mx plus c. Next, we need to compare the gradient value between two straight lines. The conclusion that we can make is if the gradient of both straight lines are equal, then two straight lines are parallel with each other. In contrast, if the gradient of both straight lines are not equal, then the two straight lines are not parallel with each other. I hope that all of you enjoy our class today. Thank you for your attention and cooperation.